And before starting my presentation, I want to tell you that today I'm going to break an important rule. And I want to ask you if you know what's the rule of a live demo. Do you know? Never do a live demo. I am the CEO of databus.pro company from Timișoara. We provide cloud services for other companies. We like to work mainly with startups, to be with them from the beginning, to analyze the requirements and to grow together. And today I'm gonna talk about OpenNebula and SaltStack. Does anybody of you ever heard of SaltStack? Okay, cool. Have you ever used it in production? Okay. But before I start my presentation, I want to do some black magic behind the scenes about my demo. And until the end of the presentation, we all know what am I doing here. Okay. Back. SaltStack. SaltStack is a different approach to infrastructure and configuration management. SaltStack thinks that its vision is really simple. It provides a building block for our infrastructure, and it thinks that offering a crypted communication bus between a lot of systems opens up new capabilities. It also is a transport control system, and its features are based on its backbone, which is a remote execution system. The remote execution system is able to communicate rapidly, asynchronous, with a lot of nodes from a central point, which is the master. But before we dive into SaltStack and what SaltStack is all about, as any kind of respectable open source project, SaltStack stands on the shoulder of the giants, and it leverages Python, ZeroMQ, MessagePack, and M2 Crypto to provide its functions. The architecture of SaltStack is really, really simple. You have a master, or you can have multi-masters from .16, communicating with a large number of minions or a small number of minions, depending on your infrastructure, over a ZeroMQ crypted bus communication. Does anybody know what ZeroMQ is? Okay, so almost anybody. AMQP, RabbitMQ. ZeroMQ is like RabbitMQ. The remote execution engine from SaltStack. After you connect your minions to the master, you can shoot functions at the minions and receive responses. For example, this function test pings the minions. The communication is done over ZeroMQ crypted bus, and the response comes back from the minion. This is how it looks like in the command line. The first thing we have to know about SaltStack is that the minions are have some immutable properties. When the minion starts, it collects a lot of information, immutable information about it, called the grains. The grains of a minion, of this minion is a CentOS machine, codename final, family Red Hat, number of CPUs, GPUs, node name, memory, and all of that stuff. This is only a part. As you can see, I've just put 3 points so I don't make a long list. There are a lot of other information that the minion gives you. Another thing that we can do with our minion is to tag it. To tag it, like to give it a role. For example, grain set val role OpenNebula frontend. On this host named Salt, I've put a grain role OpenNebula frontend. We are going to use this role in our configuration management in the next few slides, so you'll see why we've done this and how easy it is to use it. Now that we know about grains, we can talk a little bit about how do you target your minions. If you want to talk to only to a subset of minions, for example, you can target it with globbing. If you want to talk with all your web servers, you just web * test ping or whatever function you want to run. You can do it via regular expressions, salt minus E, web1, production, or development test ping, via lists, where we pass a list of minions, and via grains, where based on a grain, we target the minion and tell him to do something for us or to respond to this test ping function. The command I've ran earlier is about my demo, and my demo is a cloud built from 3 machines, an NFS server, a front end. The front end in the OpenNebula front end is also the salt master, and 2 nodes. The front end is also a node, and the node 01 machine. The networks, as OpenNebula recommends on its documentation, we have a services network that connects the machines, so OpenNebula can talk with the nodes and SaltStack with its minions. And we have a private virtual network for our machines that we are going to boot up on top of this cloud. Okay, let's see how can we configure these minions. Until now, we just talked about the remote execution engine on which we can talk with the minions. And now we are going to talk about how do we send and push configurations to our targets. The state system is the configuration management component. Whenever you install a Salt system, you have this component available at your disposal without any further configuration. It is a very powerful, fast and lightweight system, as you'll see in the next few slides. For example, let's install the OpenNebula server using SaltStack, using a state. This state is purely a file in which you use YAML to represent the state in which you want your minion to be. For example, OpenNebula packaged installed, OpenNebula service running, require package OpenNebula server. As you can see, this representation of data in YAML, it's really simple, and if you read it, for example, compare it to Puppet manifest, and you can see here, you can really understand really fast what happens behind the scenes. Let's dive a little bit and talk about the anatomy of a state. It's really important, and it will help you keep in mind that it's all just data that you transport from the master to the minion, and the minion executes parses the file and executes the functions that it finds there. The first is the ID declaration. It's the idea of the declaration that can be used in other states to include it, to require it, and stuff like that. The state declaration, SaltStack has like a lot of states. You can search them online in their documents. And the state arguments. Each state, which is a Python function, can be pushed arguments, certain arguments for each state. It also has, the state system also has the requisite statements, so you can you can make a logic of installing a software one after the other. Now, until now we have just one file. Let's see how do we do it when we have multiple files and install OpenNebula Sunstone. First, we want the server installed. And second, we want Sunstone. And we write them in separate files to keep clarity and to be able to spot problems if they appear, or misconfiguration. We just include the OpenNebula server. The include keyword in SaltStack, it means that it executes this state first, and the require is passed if the above state is executed, the function is executed with success. This is executed, the OpenNebula server. Afterwards, OpenNebula Sunstone, we install the package, we start the service, and we require the OpenNebula server service. As you can see, this is chained. First, I required in the service the package, and in Sunstone, I required the service. So whenever this state is run, first the OpenNebula server is installed, next the service is running, and afterwards the Sunstone server service package is installed, and the service is running after package is installed. Let's see what happens behind the scenes with this state execution. Whenever we call the minion to execute something, for example, OpenNebula server, salt tells the minion, based on the target, hey minion, you execute this function. The minion comes back, takes the file, OpenNebula server, parses and executes it, and responds to the master to see if there were problems or if the execution was successfully. Now, it's not fun to run one state after another. Like, we should have a lot of states that we want to run all on a minion. Here, it comes in the high state layer of SolStack. The high state is a special file named top file where you target your minions. You say that on the front end, I want to run this state and this state. The targeting can be made, as we talked earlier, via lists, grains, and regular expression. Now you wonder, what's base here? Base is the environment. SolStack also has environments. You can put your files in different directories. For example, the production environment has a directory. The development environment has another directory. You configure the master to tell them where these environments are, and the minions, based on the targeting we do in the top SLS file, and the environment, take the correct files. This is how we do it. We just develop on the development branch in Git, put the files in directory on the server, and the production is in another directory. There's a huge advantage in SolStack that it's all just about data, as we've talked before, because it doesn't need to be represented in YAML. We can represent it in everything we want, as long as we pass Salt a render module. So it can render the data and transform it in functions that needs to be run on the minion. This system is modular. You can create a new render module, put it in SolStack, and you have it, and you can write your state files in any kind of language or represent them as you like. The default renderer in SolStack is Jinja 2. Does anybody heard of Jinja templating? Yeah, cool. I thought of giving you an example with libvirt. You know, libvirt is called in CentOS libvirt, and in Debian it's called libvirt bin. So if you want a state that installs libvirt on CentOS and Debian, this will do it. Package install. If grains OS equals Debian. When I showed you grains, I told you that we are going to use them in the future. This is how you access the grains. So this file, when it goes on a CentOS machine, is going to install this package, and when it's run on a Debian machine, it's going to install the other package. What happens behind the scenes is that the same thing as before, just before parsing and executing it. In step 2, the render kicks in, renders the file, and passes the rendered file to the salt minion, which executes the functions that it finds there. Another interface in SolStack is the piler interface. This is one of the most important interfaces in SolStack because you can store highly sensitive data. Based on the targeting that we've talked before, piler data only goes to minions, to the minions that they are supposed to have access to that data. For example, MySQL passwords only go to MySQL servers. And you can also store variables or any kind of arbitrary data and access it from within the states. I'm going to show you an example with the one-admin password. The one-admin password is stored in an OpenNebula dictionary under one-admin password. The secure password, please, not this one, another. And then we access it from within our state file with this command, piler. Piler OpenNebula one-admin password. This braces tells the renderer that what follows is Jinja. And it goes in the piler, takes the password, replaces it there, and executes the command one user password and changes the password for the user one-admin from OpenNebula. OpenNebula the node communication, as you might know, is top secret. It's via SSH. So whenever I want to monitor a node, or whenever OpenNebula monitors a node or starts a VM on another node, connects via SSH to that node and sends him a command to execute it, and it receives an answer. What do we need for this is a passwordless SSH communication, and we also need to distribute the public key to the nodes. In case we want live migration, we also need to distribute the private key to the nodes, so the nodes can connect to each other and move the machines back and forward. Why I'm telling you this? Because I'm going to show you the next interface, or the next feature the SaltStack has. It's mainly a database called the mine. In the mine, you can store any kind of data you want from your infrastructure. Basically, you send to the mine this function, one public key put. This function goes, takes the public key and puts it in the mine. The mine is located on the master. The minion says mine get. This is a dictionary, just like in Piler. The name here is the name of the minion. One public key is the name of the key that holds the key. And there's the SSH key. The minion gets the key and puts it in authorized keys to be able to connect. I'm just going to show you how to use mining states, which is really simple. One admin SSH authentication. As you can see, this is another state SaltStack has. This SSH authentication makes sure that a certain key is present in a certain user's authorized keys. So with this, I'm just getting from the mine the dictionary, under the dictionary front end, the one public key get. The second one is the function. The function returns only the public key without the key. So you just push it, the key, and the key goes into your authorized keys file. Another useful system that SaltStack has is the peer communication system. Peer communication means that the minions can communicate with each other, but the minions won't communicate with each other directly. They'll communicate through the master. So the master will be a broker between two minions that need to discuss. Why do we need this? And what does the tremendous benefit that this feature brings is that we can get live data from the minions. For example, if we want from a minion the IP address from the first Ethernet interface, we can get it via this subsystem. What I want to tell you and to warn you about is that when you enable this system, be sure that you make an access list. The Salt documentation will show you how, because if you open all peer communication and not restrict it to certain functions, if somebody gets root on a Salt minion, it has root on all the minions, and you don't want this, neither do I. Whenever an OpenNebula node is up, I want to be created on the front end. For this, the first step is to tell the node to connect itself. After the node connects itself, communicates back to the Salt master, hey, I'm up. Tell the front end to create the node. And the Salt master tells the front end, create the node. And the node is created in OpenNebula without any manual intervention. And the final thing that I want to show you is the overstate. The overstate system in SaltStack, when I started to make this demo for today, I have 3 machines. And I need a certain order in which I need to set up those machines to be able to have a functional OpenNebula cloud. First, I need the network, the services network, and VM network or networks if I have more than one. The second thing that I need to do is to bring the storage online, because if I store on an NFS system, I have to bring it online, configure it and all that, and mount it as data stores under OpenNebula on the front end. The third thing that I have to do is bootstrap the front end and Sunstone. And the last thing is to bootstrap the nodes and connect them to OpenNebula front end. This is what I'm doing for this demo today. First thing, overstate takes a file just like the top file I showed you a little bit earlier, in which you just say run in the first step, go to all nodes and run the network states. In the second step, in the third and the fourth step, just go to the NFS server and run the storage state. In the fourth, fifth, and sixth step, go on the front end and run those states and etc. Each run, if it's not successful, the overstate system stops. So basically you have this workflow of bootstrapping an application, or in our case OpenNebula, in 8 easy steps. Besides this, SolStack has lots of other features that are that can help in certain situations. These, for me, are the basic ones, and they can really change your life or change your infrastructure and how you manage it and how you configure it and deploy it. A few words about how I use SolStack with OpenNebula. I use it to deploy OpenNebula first, using all this system that I showed you. And in the second phase, I use SolStack to auto-configure virtual machines. In OpenNebula, I have a hook that creates the keys for the minion and the master, and announces the master to put the key of the minion in the correct place and push the keys to the minion via the contextualization system. And when the VM boots, I just execute high state. And I also pass the grains in the templates. So I have a virtual machine that starts up, knows that, hey, I'm an OpenNebula frontend, for example, but this is, or an Nginx web server or whatever, and I need to execute these states. And whenever it boots, goes to the master, it's already authenticated with the master, takes these states and execute it and boots up. Via this system, via the system, the peer system, the mine and all that, I communicate whatever I need with other nodes whenever I'm setting up a new VM. This is really powerful. I couldn't have done this without SolStack, and I couldn't do it until I've met SolStack. This SolStack, basically, it's split it into functional parts. It's the flow part, the flow meaning that it gives you control over your minions, and you have this flow and you can talk from minion to minion or from minion to another minion via the master or get the mine. And the second is the state, where the state is the state in which you want your infrastructure or your server to be at a certain point in time. As conclusion, two simple tools together equals squared power. Since I've used this OpenNebula and SolStack, we started to be much more productive and to get things done really, really faster. Salt is fast. We'll see how fast it is in a second. For me, both are easy to use. I came from a systems engineer background, and when we started to look for a cloud computing solution, I've tried to go to other tools like CloudStack and OpenStack, but I found them too difficult, and I've settled down for OpenNebula, which was the best decision I've ever made, because you can like hack it and make it for your needs, and this is really, really cool. And another thing that I've noticed using SolStack is that you take SolStack and you use it for a small part of your needs, and after a couple of months you see that, hey, come on, I can't live without it, and it can morph in whatever situation you have. We use SolStack to deploy LXC containers, to deploy web applications, to deploy infrastructures. We use it for everything, and it works. Questions? The question was that SolStack, what does it wraps up what Puppet and mCollective do together? And the answer would be yes. This is what it does, but it does much more. And the fact that you have all integrated and that you can extend it really easily, it's an advantage. And another thing, and another big difference between them is that Puppet is in Ruby and Salt is in Python. So this depends on the skills you have and depends on your capability to acquire new skills in short time. But I found Python to be much more easier to learn than Ruby. Okay, you just have to put in your template the salt master IP address. You put the salt roles, the grains that you want your minion to have, and you modify the context scripts, or you make a new script. Oh, for the host. For the host, you just bootstrap the host. You install salt minion, connect it to the master, and from the master you say you have this role, this role, this role, this role, and afterwards you say just take the states and execute. This is how you can do it. Oh, to create the host in OpenNebula. Okay, I wanted this presentation to show you the surfaces and to show you the features that SaltStack has, and I didn't want to go in like details. I add the OpenNebula node in the front end via a state file in which I say run this command on the front end. That's basically it. But you have to have peer system activated for this to work, so you can say from the minion to another minion, hey, do this. But afterwards, you can do that. I can show you afterwards the states, so you know what I'm talking about, if you are interested, and that's cool. Ah, okay. You get informed like this whenever you run some states. I'm sorry you cannot see it, but yeah, cool. Thank you. This is the output of a state. For example, look, state sysctl name, net IP version 4 IP forward, function present, result true, comment updated, value. This is when you run it interactively if you want, when you run state by state, or when you run high state and you're on a terminal. If you run it automatically from cron, for example, or from the system SaltStack has inside to schedule functions, you have another Salt interface called the returner. The returner can return data to another system, and we use Sentry. We just take all this and send it to Sentry via the returner whenever a high state is run. And from Sentry, we manage it with emails and stuff. Welcome. Okay.
What are the requirements for the minions?
The requirements for the minions?
So you need to install the minion software on the minion nodes.
Yeah.
Is it just a single RPM or Debian package, or does it require some Python environments or whatever?
Okay. The guys from SaltStack package SaltStack for CentOS, SUSE, and Debian, and Ubuntu. So you have the packages in the repositories, just apt-get install them. You need the 0MQ libraries and some other Python libraries that SaltStack use internally.
Okay, and the minion is a process that constantly is running, or?
Yeah, it's a process, it's an agent.
Okay, and it's listening to some TCP port or whatever.
Yeah, this is connects to the master on a certain point, or on a certain TCP port. 0MQ opens up 2 ports.
And how I've read about the security. It is some kind of self-made security that SaltStack uses to communicate between the master and the minions.
Yeah,
Why don't they use well-tested stacks like SSL or something like that?
That I do not know. You'd have to ask the developers. But I know they use M2 crypto, and from .17 they are starting to implement a modular transport system, and the first transport system is SSH. they are going to transport over SSH, not over that library. And that's a good news for everybody who's interested in security and the community, because this question was raised on the mailing list long time ago. Okay, so just switch to one admin. We have two hosts on. We have a VNet. We have an image. We have a template. Okay, and if we want to check and see that it really works, we just go to Sandstone. Here. Establishing. Oh, it doesn't work because my VPN tunnel is not connected. Do I have time to or not? Oh, 4 minutes, okay. Just want to connect and... Yeah, it takes a little bit of time. But this is basically about it. Other questions? Is there a marketplace for SourceTag to share the modules? This was the question, right? There is. On GitHub, you can find the repositories under SourceTag named SourceTag formulas, on which you can find a bunch of formulas. They've just started this effort, and people from the community are starting to put there. I can tell you to really check that repository, because you can learn a lot of things about how people are writing states. He was first. Was not that good? Good. Very good question, and I can honestly tell you that until now I haven't found a shortcoming. Like, the packages come after 2 days after the release. So, and you just install them, they are stable, and everything works. The minions immediately connect to the master, and it works. I can communicate from within my infrastructure in the two-tier infrastructure in which you have the app servers in the back and the web servers in the front. I can communicate however I want, and I can deploy OpenNebula and other tools like as fast as you saw earlier. So I couldn't find one, but if I find one, I will tell you. Simon? The question is that if I plan to share my OpenNebula files, of course, my OpenNebula states, of course, but I need to polish them a little bit. And afterwards, I will make them public and sustain them on the way to improve them and stuff like that. So this is basically it. Okay, the tunnel is connected. Waiting. The internet is working. Good. Not best. Come on. See why you should never do a live demo. Yeah, anyway, this was about it. Yeah, I think my time is over.